Rational expressions, adding and subtracting. This is a very unconventional way of adding and subtracting rational expressions. But I think overall you'll appreciate the simplicity of it. And towards the end of the video, I'll explain some of the downfalls of it. So let's try half plus 1 over 3 and add in this unconventional way. To add these two fractions, you do it this way. 1 times 3 is 3. 2 times 1 is 2. Make sure you leave a space. And then divided by 2 times 3, 6. There's a plus sign here in the middle. There's a plus sign here. And we have this as 5 over 6. And that's it. Let's try another one. 1 over x plus 3 over 5. And again, we start over here on the left. 1 times 5, 5. And then the bottom over here, x times 3 is 3x over x times 5, 5x. And then we have a plus in the middle. Let's say we had negative 1 over 3 plus 2 over x squared. Not a problem. First, we're going to worry about multiplying. 1 times x squared. And 3 times 2, which is 6. Divided by 3 times x squared, 3x squared. We worry about multiplying, and then we worry about signs. There's a negative here on the left, so it goes over here on the left. There's one in the middle. We'll put it in the middle. And that's it. We're done. Let's try this one. 3 over x squared plus 1 over 5. Again, 3 times 5, 15. X squared times x is x squared over 5 times x squared is 5x squared. There's a plus in the middle, and we're done right there. All right, let's try the next one. Negative 2 over 3 plus 6 over 2x. In this situation, it's best to reduce the fraction before we start. So let's reduce. 2 goes into 6 3 times. 2 goes into 2 1 time. And don't forget the x. So let's do it. 2 times 1x is 2x. 3 times 3, 9. All over 3 times x, 3x. And then we have a negative on the left. We have a plus in the middle. And that's it. Let's try another one. 5 over 3x plus 4 over x. Now this is going to demonstrate a little bit on what happens, why this method is not the best method to use when using rational expressions. So here we go. 5 times x gives you 5x. And 3x times 4 gives you 12x all over 3 times x gives you 3x squared. There's a plus in the middle. And now we're going to add 12x plus 5x gives you 17x over 3x squared. And this is what happens with this method, this unconventional method. Sometimes you have to reduce in the end. In this case, the x over the x squared we need to reduce. And so this becomes 17 over 3x. All right, let's do another problem here. 3 over x plus 2, take away 5 over 4. Okay, you'll notice here that the denominator here is a binomial. So let's put parentheses on it so that we understand that anything we do with this binomial, we're going to have to multiply it to these two terms. So let's try it. 3 times 4 is 12. And 5 times that binomial, so this is 5 times x plus 2 all over 4 times x plus 2. And in the middle, we have a subtraction. All right, now we have to multiply the binomial out. This is negative 5 times x and negative 5 times 2. That's very important. We've got to keep that negative there. So that's going to give me 12. And this is the 12 right here. And then negative 5 times x is negative 5x. And negative 5 times 2 is negative 10. All over 4 times x, 4x. And then 4 times 2 is plus 8. Then we combine like terms if there is any. Here we have negative 5x. We're going to put it over here. And 12 take away 10 is going to give me plus 2 all over 4x plus 8. One main reason why you would want to use this method, this unconventional method of adding, subtracting rational expression, is if you were taking a multiple choice test, especially if you don't have to show your work. But there are some pitfalls. One, sometimes, like in this example right here, you have to reduce. And it can get very complicated, very complex. Sometimes you have to factor and then reduce. Another thing that this method doesn't really focus on is identifying the lowest common denominator. And simple fractions, like the first one that we did over here, you know, this is the lowest common denominator, 6. But as we move on to more complicated rational expressions, after you multiply, it doesn't give you the lowest common denominator. You're not working with that. And there's some advantages of knowing the lowest common denominator. But overall, this method will work for you.